On August 5, 2025, the Federal Aviation Administration, or FAA, issued a critical safety alert that would soon dominate headlines and spark intense debate across the aviation industry. The announcement sent shockwaves through the aviation world, leaving pilots, airline executives, and passengers alike searching for answers and reassurance. The FAA's warning specifically targeted the Boeing 787, 9 and 787, 10 Dreamliners, two of the most advanced and widely used long-haul jets in the world. At the heart of the alert was a potentially catastrophic flaw in a critical safety device, the Ram Air Turbine, or RAT. According to the FAA, a key structural part of the RAT had been manufactured using a weaker, commercially pure titanium, rather than the required aerospace-grade alloy designed to withstand the extreme stresses of flight. This seemingly small error carried enormous consequences, risking the complete loss of emergency power in the event of a main system failure. Even more alarming, the FAA warned that the RAT could potentially detach from the aircraft mid-flight, a nightmare scenario that could leave a jet without vital backup systems at 35,000 feet. The news immediately raised urgent questions. How could such a basic materials failure slip through multiple layers of inspection and quality control? Boeing's shares tumbled, airlines scrambled to assess their fleets, and the public was reminded that even the most technologically advanced jets are only as safe as their smallest, most overlooked components. The FAA's directive was more than just a technical bulletin. It was a wake-up call about the importance of oversight, transparency, and the hidden dangers lurking within today's complex global supply chains. For passengers everywhere, it was a stark reminder that aviation safety is a chain, one that depends on every link from the tiniest bolt to the largest jet working perfectly together. The Ram Air Turbine, or RAT, is the ultimate backup system on modern jets. In a total engine failure, the RAT deploys into the airstream, spinning like a windmill to generate emergency power. This power keeps essential flight controls, navigation, and communication systems alive, giving pilots a fighting chance to land safely. Without the RAT, a powerless jet becomes an uncontrollable glider. Every part of the RAT system is engineered for reliability, expected to work flawlessly, even after years of dormancy. The idea that its critical fittings could be compromised is deeply unsettling for pilots and engineers alike. If the RAT fails or detaches, the last line of defense in an emergency vanishes. The FAA's alert centered on a shocking discovery. Critical forward fittings for the Ram Air Turbine, or RAT, on the Boeing 787 were manufactured using the wrong type of titanium. The RAT is a small emergency wind turbine that deploys in flight to provide backup power if the main electrical systems fail. Its reliability is absolutely essential for the safety of everyone on board. Instead of the high-strength grade 5 titanium alloy specified for this demanding application, some fittings were made from a much weaker, commercially pure titanium. This material lacks the necessary strength and durability to withstand the intense forces experienced during an emergency deployment. This substitution created a hidden and potentially catastrophic danger. Under the stress of flight or during an emergency, the weaker fitting could crack, deform, or even break apart entirely. In the worst-case scenario, the RAT could fail to deploy or detach from the aircraft, leaving pilots without a crucial backup system. Investigators traced the faulty parts back through a complex and global supply chain. The unapproved titanium originated from a supplier in China, raising questions about international sourcing and oversight. Multiple major companies were involved in the process: Spirit AeroSystems, Collins Aerospace, and Boeing itself. Despite the involvement of these industry leaders, the error went undetected for months, slipping through layer after layer of supposed safeguards. This wasn't a design flaw, but a breakdown in the systems meant to verify materials and ensure quality control. The failure to catch the substandard titanium exposed a critical weakness in the industry's safety net. The incident revealed a systemic vulnerability. How could uncertified metal pass through so many checkpoints, inspections, and audits without being flagged? It raised urgent questions about the effectiveness of current quality assurance processes. The risk was not theoretical. If the RAT failed during a real emergency, the consequences could be catastrophic, potentially endangering the lives of everyone on board and undermining trust in aviation safety. In the aftermath, the aviation industry was forced to confront the dangers posed by increasingly complex supply chains and the potential for lapses in oversight. The incident served as a wake-up call, highlighting the need for more rigorous checks and greater transparency at every stage of aircraft manufacturing. The crisis began quietly in February 2025, when Boeing first flagged the material issue and recommended voluntary inspections. Airlines started checking their fleets, but the true risk wasn't yet clear. By late July, the FAA moved to make inspections mandatory, signaling the problem was too serious for voluntary action. On August 5, the FAA issued its public directive, mandating immediate checks for all affected 787, 9 and 787, 10 aircraft. The announcement turned an internal concern into a global news story, forcing airlines to act fast. The escalation from internal bulletin to regulatory order showed the system's checks and balances in action. The FAA's intervention marked the point where voluntary measures were no longer enough to protect safety. As the FAA's sweeping directive made headlines across the globe, a recent tragedy brought the issue of aviation safety into sharp, painful focus. The world was already on edge, but now the stakes felt even higher. In June 2025, an Air India 787-8 crashed shortly after takeoff, sending shockwaves through the aviation community. Investigators quickly discovered that the aircraft's Ram Air Turbine, or RAT, had deployed just moments before the devastating impact, raising urgent questions about what went wrong. Although this particular model wasn't among those affected by the titanium flaw at the heart of the FAA's warning, the crash made the threat of RAT failure feel immediate and terrifyingly real for both experts and everyday travelers alike. The timing of the Air India disaster, coming so soon after the FAA's alert, fueled a wave of public anxiety. For many, the technical distinctions between aircraft models and specific flaws blurred together, replaced by a growing sense of unease about flying itself. The incident underscored the life-or-death importance of the RAT, a device designed to provide emergency power only in the most dire situations when all else fails. Suddenly, a rarely discussed backup system was thrust into the spotlight. For regulators and Boeing, the crash was a sobering wake-up call. It highlighted the urgent need to ensure that every backup system, no matter how rarely used, must be absolutely infallible. The margin for error had never felt so thin. The psychological impact was profound. Suddenly, the public saw the RAT not as a technical detail buried in a manual, but as a last desperate hope in the face of disaster, a symbol of both vulnerability and survival. The Air India tragedy, though ultimately unrelated in cause to the titanium flaw, made the FAA's warning impossible to ignore. It forced airlines, regulators, and passengers to confront uncomfortable questions about risk and trust in technology. It was a chilling reminder of what's truly at stake when safety systems fail, a stark illustration that in aviation, every safeguard matters, and every failure can have devastating consequences. The FAA's directive required immediate inspections of all 787, 9 and 787, 10 RAT fittings, no inspection, no flight. Airlines had to use advanced testing methods like eddy current analysis and X-ray fluorescence to verify the titanium's grade. Maintenance schedules were upended, aircraft grounded, and flights delayed as airlines scrambled to comply. The directive's reach was global. Regulators in Europe, Asia, and beyond quickly adopted the FAA's requirements. Airlines like Air India, with new 787-9s, faced direct operational impacts. The cost and disruption were significant, but safety came first. The coordinated response showed the aviation system working as intended, swift, unified, and uncompromising on safety. The crisis tested the industry's ability to mobilize and adapt under pressure. In the end, the priority was clear: passenger safety above all else. The titanium scandal exposed the fragility of aviation's vast global supply chain. A single batch of substandard metal, sourced from China, slipped through multiple suppliers and quality checks before reaching Boeing. The breakdown revealed gaps in documentation, testing, and oversight at every stage. Sanctions on Russian titanium had already forced manufacturers to seek new, less vetted sources, increasing risk. The incident showed that paperwork alone isn't enough. Trust must be backed by rigorous independent verification. The cost to Collins Aerospace for switching suppliers hinted at deeper, long-standing concerns. The lesson was clear: in aviation, every link in the supply chain must be unbreakable. The rat crisis struck at Boeing's reputation, raising questions about its quality control and oversight. The problem wasn't just a faulty part, it was a symptom of deeper issues in globalized just-in-time manufacturing. The reliance on supplier paperwork created a false sense of security, masking real vulnerabilities. Boeing now faces pressure to overhaul its supply chain management, with more direct oversight and advanced verification at every step. Restoring trust will require transparency, accountability, and a shift from trust-based to verification-based systems. For passengers, the episode is a reminder that safety is built on relentless vigilance, not assumptions. The future of aviation manufacturing depends on learning from these failures and proving that lessons have been truly absorbed. Only then can Boeing and the industry rebuild public confidence. The 2025 Boeing rat crisis was a wake-up call, but also proof that the aviation safety system can work. The flaw was found, communicated, and fixed through decisive regulatory action. The key lesson: end-to-end material traceability and independent verification are non-negotiable. Manufacturers must take responsibility for every supplier, right down to the raw materials. The FAA's strong response showed why independent oversight is essential. The industry must now invest in new technologies, foster transparency, and build a culture where safety is everyone's job. Complacency is the enemy. Continuous improvement is the only way forward. By embracing these lessons, aviation can remain the safest way to travel.